This is an informational video about Base64 encoding in approximately 5 minutes. What is Base64 encoding? To put it in one sentence, it's basically an encoding style where binary data is represented by a max of 64 characters. Why do we need Base64 encoding, or for that matter, any encoding? Well, originally, email applications used to send human-readable text characters across. But nowadays people attach executable zip files, JPEG files and whatnot, which are binary data. So these are not human-readable characters. So that's why we need to do some sort of an encoding of these binary characters. Well, why can't we send binary data as is? Well, because binary data has a sequence of, bits, which is like ones and zeros, and there could be a byte, which is a sequence of 8 bits representing zeros with all zeros in it, which is a null character. Well, what is the big deal with null character, you may ask? Null character historically in applications written in, for example, C or C++, represents an end of string. So applications written in, say, C, if it encounters a null character, it'll think, oh well, that's the end of the input string, and it won't read any further. So that would be an issue if you're sending binary data as is. Well, now that we know that we can send binary data as is, we'll have to encode the binary data into a format which doesn't break certain applications. So is Base64 encoding the only solution? Not really. There is a very simple encoding, which is the hexadecimal encoding, which is not used because it's not as efficient as a Base64 encoding, because it uses more characters than the Base64 encoding. We'll basically see a comparison between the hexadecimal encoding and the Base64 encoding for you to understand why the Base64 is more efficient. In this case, the example is a long 3-byte binary string shown below. We will see in the next slide how we convert it into hexadecimal and Base64. On the left side is shown the hex encoding of the binary data. So as in hexadecimal, we group 4 bits, the whole binary string, into groups of 4 bits each. And as you can see on the left side, we have those grouping, and it translates to B59244, which is the hex equivalent of that long 3-byte binary string, which, as we can see, is 6 characters. On the right is the Base64 encoding shown. Here we break the binary stream into groups of 6 bits, and as you can see there, 6 bits out of 3 bytes, we get 4 groups of 6 bits. Since a byte is 8 bits, so 3 bytes is 24 bits. If we convert those values into decimal, we get those values shown there. And to get to the Base64 encoding values, there's a table lookup, which basically says 0 to 25 will be mapped to capital A to capital Z. That is, 0 will be capital A, and capital Z will have a value of 25, and so on. 26 to 51 is lowercase a to Z, 52 to 61 0 to 9, and 62 is plus, and 63 is the front slash character. So as you can see here, you can represent all the values by looking at these mapping table. We cannot exceed 63 because each group is 6 bits, and the highest value you could have in a 6-bit is 63. So this is basically Base64 encoding. As we saw in the previous slide, Base64 encoding is more efficient than hexadecimal because the 3-byte binary string mapped to 4 characters as opposed to 6 characters if we had used the hexadecimal encoding. Final couple of points in Base64 encoding is, what if your original binary string is not 3 bytes or a multiple of 3 bytes? What we do is we add some extra bytes which has 0 values in it. Let's take, for example, a 4-byte binary string. It's not a multiple of 3, so we pad 2 0 bytes. Now it's 6 bytes, so which is a multiple of 3. And for every byte we added, every 0 byte value we added, we have to represent it with an equal to sign. So after we finish our encoding, we just add an equal to sign at the end to indicate there was some padding. So in our case, since we padded 2 bytes, we have to put 2 equal to signs. The other point is your original binary string is definitely going to be more than a few bytes. It's probably going to be a few hundred bytes or so if you're attaching a JPEG image or something. So if this is converted into a Base64 encoded string, it's going to be pretty long, and that can cause issues too. Certain applications may not be able to handle such a long string, So what we do is we break this original or the encoded string, the Base64 encoded string, by sticking in a new line carriage return character after every 76 characters. So this makes it easier for certain applications to handle it. That's it for this Base64 encoding informational video. Appreciate you leaving any comments on how to improve what I've presented, and have a good day. Bye.